This archive represents a staggering volume of patents bearing the name Tesla, with a timeline spanning from the 1880s through to the present day. At first glance, the collection appears scattered. It is difficult to see how an 1898 patent for a remote-controlled boat shares any DNA with a 2026 AI car battery. Nikola Tesla registered around 300 patents in his lifetime, and the modern company sharing his name has filed thousands more. Understanding how they connect requires looking at these inventions individually. Despite the century dividing them, these patents follow a consistent engineering philosophy: the avoidance of mechanical friction and the removal of moving parts. Tesla looked past the mechanical complexity of gears, opting instead to master the physics of fields, fluids, and electrons. Historically, managing electrical current relied on clumsy, friction-heavy mechanical switches, physical components sparking and grinding together just to transfer power. In his 1883 AC motor, Tesla used alternating current to create a rotating magnetic field, driving the central rotor without mechanical commutators. Tesla Inc. applies the same logic to modern energy storage. The 4680 battery increases efficiency by removing internal mechanical structures, like traditional tabs. The recent variable EV transmission patent follows this same path. Instead of using physical cogs to shift gears, the system switches between different semiconductor materials in real time to manage the flow of electricity. By focusing on the electron, energy can be manipulated, stored, and transferred without the wear and tear of physical contact. To move beyond physical wires, you have to utilize invisible energy fields to send both power and information through the air. This 1891 Tesla coil used polyphase alternating currents to create high-voltage sheets of electric flame. It was the first step in a vision to transmit electrical energy without any physical tether. By 1897, Tesla applied these field manipulations to communication, transmitting wireless signals 25 miles across the Hudson River, paving the way for the radio. He placed a receiver inside a small boat and steered it remotely. This 1898 teleautomaton proved invisible signals could pilot machines across a distance, laying the foundation for modern drone technology. Today, that wireless heritage connects modern hardware. The Optimus robot and Tesla vehicles use V2X communication to exchange real-time data with their surroundings, allowing them to navigate complex zones without a single physical connection. These invisible connections allow individual machines to coordinate as a network, sharing data and navigating the world in the background. Managing physical matter, like air, water, and coolants, usually requires pumps and valves, which are often the first parts to fail. The 1913 Tesla turbine offered a different solution. Fluid grips smooth, flat disks via the boundary layer effect, generating power through adhesion. The 1920 Tesla valve achieves similar results using internal geometry. Liquid flows smoothly forward, but swirls and halts in reverse, zero moving parts. This principle appears in the modern lens cleaning system patent, which uses fluid dispensation to autonomously clear debris from FSD cameras and Optimus sensors, keeping the hardware functional without manual scrubbing. Tesla even applied these fluid dynamic principles to aerodynamics in his final 1928 patent for a vertical takeoff and landing aircraft. By relying on internal geometry rather than moving valves, these systems reduce the points of mechanical failure commonly found in traditional hardware. Nikola Tesla lived in the mechanical Victorian era, yet maintained a radical vision for engineering. Looking at these patents together reveals a consistent engineering language, one that prioritizes invisible forces over physical contact. That vision is realized today in our infrastructure. Every time an EV manages heat, a drone pilots itself, or a grid routes renewable energy, it is utilizing the architecture he described. The true scale of the Tesla brand is measured by what we don't see: a world built on the physics of fields, fluids, and electrons.